Good afternoon. This afternoon we're joined by Professor P.V. van der Walt. He's a retired professor. Good afternoon, P.V.
Good afternoon, Tinus. How are you?
I'm doing well, thank you. I'm so glad that you've joined us today. Are you well?
I'm fine.
P.V., so I want to start with a few questions. You've obviously have a wealth of experience in the discipline of electrical and electronic engineering. You've gone through starting up a business, through teaching. You've really done a lot, but let's start at the beginning. What got you into engineering?
A cousin of mine, when I was about more or less in standard 6, he got me interested in electronics. He was building amateur radio sets. And there I got interested in high fidelity, and I started designing my own amplifiers without having a very good clue of what I was actually doing. But they worked, and they grew more powerful. At one stage I had the whole house bombarded with sound, and my sister up in arms. She was a musician who couldn't hear herself practicing on the piano. And so I went on, and I got interested in tone controls and all those things. I designed them, but I didn't really know how they worked. So when the chance came to study engineering, well, I just went for it. And at university, I really found out how to design tone controls. In fact, a tone control is a very simple example of a filter. And designing microwave filters later became a mainline activity of mine, to design all kinds of microwave filters for radar systems. So it all started with a little boy building amplifiers, getting interested in tone controls, hearing about this magical variable S that I had no clue what it was, going to university, finding out what was S, how do you use it, and I'm actively and very actively using it to this day.
Amazing. So one of the things that you've done that's quite exceptional is you were one of the pioneers in setting up a company called Reutec, the starting of Reutec.
Yeah. Well, I think if you look back at it, Reutec Radar was probably the first spin-off company out of the faculty. Now, in the first year that I started teaching, I had a student in my class, Gerrit Pretorius. We called him Bull. And he did very well for himself outside, and he became the chief executive officer of Reutec Systems in Pretoria. That was in 1985, roundabouts there. In those days, there was an arms boycott against South Africa. We couldn't buy radars. We didn't have the capability to manufacture radars. And Gerrit decided he was going to change it. So he made an agreement with an English company to get them to support him in developing radars locally. And he also asked me if I would assist. I was then a professor, happily teaching electronics and microwave theory and filtered theory at university. Well, I immediately said yes. He sent me on a little trip to England to a radar factory so that I could look at what does a radar look like. And while I was in London, I met him, and he was very, very downhearted because the company who would have supported him decided not to go ahead. And there we were on our own. So, well, he was very downhearted, and he wanted to cancel the project. And I said, well, let's carry on. I'll come and help you. So the next year, the university granted me a very special leave. I received my university pay, but the company paid in my costs. And I went to start up the company. I also had about 6 or 7 students, master's students in my class, and Gerrit approached them with an offer to come and join the project, and they could use the project for their thesis work, which was in line with what they were doing because they were studying high-frequency electronics. So I and my team of students with a few other engineers from Reutec, and 1 or 2 students of Professor Klutter doing antennas, we started working and we started to build a radar.
I'm really interested in this move into industry from academia. So there are a few things that I find particularly interesting. The one is that academia seems very far removed from industry, and it's something that I've had to grapple a few times with myself. It's just the fact that we teach quite a lot of theory and we do practicals, but then when you get into industry, it's a whole new ballgame. So could you maybe highlight some of the challenges that you faced in that transition?
Well, yes, Tinus. There is a saying that some people like to tell students that what you're learning today, you won't ever use again, or it will be old hat in 2 years' time. I want to tell you that is total and utter nonsense. The engineering world runs on a good foundation, a good scientific foundation, a good scientific mathematical foundation. And there are things that change rapidly in electronic engineering, especially. After starting the company, I became dean of the faculty. So I operated a desk for about 10 years. And after that, I went to work for the company. And it was 10 years since I had touched a transistor or anything like that. Well, I got there, and as I said, everything had changed. The components were unrecognizable. But there was one thing that did not change, not one bit. That was the theory, the science behind it, the mathematics. That didn't change. So I very soon found my feet. Now, at university, you put a lot of weight on practical experience in the laboratory, which is a good thing. But there's one big difference between a university laboratory and an industry laboratory. And that is the specification that has to be met.
Yeah.
In university laboratory, you try out new things, and if they work more or less well, you are very happy.
Yeah.
In the industry, you agree on a contract, and that contract specifies performance.
Yes.
And I was rather surprised when starting to develop my own frequency synthesizer that I actually had to meet these requirements.
I want to also ask you about the skill set. You've spoken a bit about the skill set that engineers have, this fundamental theory, fundamental mathematical skills, etc. What are the non-fundamental skills that you found most useful in engineering? So more of the soft skills that you picked up rather than the fundamental knowledge.
Well, Tina's a very important skill is communication. Language is also an important thing. As one professor once told me in a meeting where the engineer was rather loose with his terms, he said, words have meaning. That's something that engineers don't always appreciate, that words have meaning. The other important thing is to be broad in your outlook. When I was a professor, boy, you do research in a very, very narrow field. You are interested in microwave filters, and that becomes the world, more or less. When I became dean, I discovered there were other worlds as well. And I found that, civil engineering is very interesting as well. The work they do with dams and rivers, chemical engineers, they are all different kinds of engineers, types of engineers, but all very interesting. And that is where I, in industry, found that I had to broaden my base. You must be interested in a wide range of things, because industry can't make money by building a very narrow product line, say microwave filters in South Africa. You won't make a cent. You've got to develop systems.
I want to ask you one final important question. You are in a privileged position where you've seen things progress for the last few years, and you still keep on top of technology. You're still involved. You see things progressing. Where do you see things going in the next 10 to 20 years, specifically in terms of the skills required from engineering students?
Well, I had a colleague, or I have a colleague, Professor John Kluter, who likes to say that you must be very careful when you make predictions, especially if they have to do with the future. It's very difficult to say where we are going to be in 15 years' time at the rate things are developing. You will probably see an invasion of electronics into the human body. We already have artificial ears, electronic ears. That will probably develop at a very strong pace. We have the communications infrastructure just exploding. The Internet of Things. You now have motor cars that are online all the time, talking to back to the factory to tell the factory what's going on in the engine. It is just mind-boggling to think at everything that's being communicated. You wonder whether information isn't going to get in short supply sometime, but it seems to be infinite. I would like to give some general advice to your prospective students, and that is get into the business of opening doors. You know, with a very good matric pass, maths and science, good grades, you can go and study engineering, you can go and study medicine, you can take a BSc course, you can study law, you can study accountancy, you can become an actuary, as long as you have good maths and science grades in matric. If you don't have them, a lot of these doors close and you can't go in. Okay, so you've opened the door to engineering by doing well at school in maths and science, and the rest as well. When you get to university, you once again can get into the business of opening doors by performing well, by doing your best. If you pass the engineering degree with an average higher than 60, a door opens. You can study masters. If you pass the engineering degree with an 80% average, a few doors overseas will open wide. And Cambridge would like you to go and study there. So get into the business of opening doors. You know, if a door opens, you don't have to go in if you don't want to. But if it's closed, you can't go in.
You can't.
That's my advice. Work hard. Your future is being determined right now in matric. And you're in a more serious business than you perhaps realize. Open those doors. It's summarized by Hamming, who said, you know, if a scientist knows what he's doing the wrong thing. And if an engineer doesn't know what he's doing the wrong thing. So yes. Science is about finding out how does nature work, and engineering is about making nature work for humankind.
Devi, it's been an absolute pleasure. Thank you very much for sharing your insights, your wisdom, and your time with us. I'm sure everybody will be greatly pleased to have a look at this. Thank you very much.
Pleasure, Dinas. Thanks for the opportunity.